All right, we're going to talk about the structure of water and the emergent properties of water. Water is made up of two hydrogens and an oxygen. And these are held together by a covalent bond. And covalent means sharing electrons. So what happens is the little electrons are Alright, so these little, I forget which way I was going. These little electrons are moving around, but oxygen is big and it doesn't share equally, so it gets the electrons most of the time, which gives it a slight negative charge, which means the hydrogens don't have the electrons and they get a slight positive charge. This is what polar means. You have two opposite charges on ends. Now what happens because of these polar charges, water molecules are attracted to one another. And opposite charges attract, so there's your oxygen and your hydrogens are over here with their negatives. So that means you'd have a hydrogen with its negative there. Big oxygen. And another oxygen with its negatives. This holding together because of these slight positive and negative charges is called a hydrogen bond. This is going to be responsible for many of water's properties. Cohesion is water sticking to water by those hydrogen bonds. Adhesion is the water molecules, that's supposed to be a W, water molecules sticking to something else. Still, because of that interaction with the hydrogen bonds, sticking to some other surface. Water is pulled up in plants by cohesion and adhesion. That's how water gets from the ground to the very tip top of the tallest trees, right? Surface tension is how difficult it is to stretch or break the surface of a liquid. Water has really high surface tension. And you can see little water strider bugs, right, on top of the water. They're able to do that because of the surface tension. And it's those hydrogen bonds on the surface and them those below it. And it also causes water to bead because it's going to make the smallest or a shape with the smallest area to volume ratio. Then you have moderation of temperature by water and heat. High specific heat, this is resisting temperature. Oops, hang on. Changes. Resisting temperature changes. And so it's going to release and absorb heat. The specific heat of water is 1 cal per gram per degree Celsius. Water forms hydrogen bonds to absorb heat and breaks hydrogen bonds to release heat. If you think large bodies of water, they act as a heat sink. If you live on the coast, the summer isn't quite as hot, the winter isn't quite as cold. Doesn't always have to do with your latitude. It has to do with the fact that the water absorbs heat during the summer and releases it on colder days or at colder times. And this is one of the things that helps Earth keep a temperature range that's suitable for life. Evaporative cooling. This is the after effect of cooling of it on a surface when liquid evaporates, like sweat. Think of sweat. Let's see. You'll often hear water called the universal solvent. It doesn't dissolve everything. Think of oil and water. But though it'll dissolve polar things. And we're going to talk about this more on the next slide. Water expands as it freezes. And so it's less dense as a solid than a liquid, which is why ice floats. And it is most dense at 4 degrees Celsius. This prevents deep bodies of water from freezing from the bottom up. Ice forms at the surface, insulates the water below, and makes the transitions between seasons less abrupt. We have a few terms here, and I forgot one. Just add it in here. Solution. A solution is a liquid that is a homogeneous mixture of 2 or more substances, meaning that you can't tell the difference. It all looks the same. And if you hear aqueous solution, that means that the solvent, in this case, is water. Aqueous solution. Solvent is the dissolving agent. And the solute is what's being dissolved. The way water dissolves something, especially ionic compounds like salt. Hang on. All right, here's your salt over here, and it is made up of sodium ions and chloride ions, and the water actually will form hydration shells around these guys so that all of their possible bonding is taken up. It makes them unavailable for other bonding. Hydro in each case means water, right? So this is water loving, and hydrophobic is water fearing, like a phobia. Water-loving solutions are polar, typically, or have a charge. Water-fearing are non-polar. Think of oil. All right. This is going to be the end of our water video. Make sure to watch the pH video next.